Welcome! We hope that this video will help science teachers perform an inventory of their laboratory chemicals. Encouraging the practice of doing such an inventory each year is a major goal of EPA's School Chemical Cleanout Campaign, or SC3 for short. The SC3 program was started in 2004 and continued until 2010. The Florida Department of Environmental Protection, or DEP for short, managed the program for EPA in Florida. About half the high schools in the state were visited, and several hundred teachers received training in chemical management. The SC3 program was a response to a history of accidents and incidents involving chemicals in schools. The goals of the program were to remove excess, unused, deteriorated, or out-of-date chemicals from schools, to identify potentially dangerous chemicals that should not be present or used at all, ensure that all chemicals are managed properly, encourage the removal of all mercury and mercury compounds from schools, and in general offer assistance to schools to improve their chemical management procedures. The first step in accomplishing these goals is to inventory the chemicals already present. Who should do this inventory? Only someone who has technical knowledge about the nature of chemicals, and that is almost always the science teachers. It's best to have two people perform the inventory, but never a student. Depending upon the situation, a comprehensive inventory can take anywhere from 15 minutes to 2 weeks to accomplish. Before beginning the inventory, it is a good idea to review which chemicals are high risk. There are several lists to consult, and most of them are posted on DEP's website. There is one called Excessive Risk Chemicals of about 140, and many school districts have banned the use of any chemical on this list, so you need to know if you have any of these chemicals. Another list is the high-risk chemicals, which, although they're not banned, do require very special management, and they should be kept in only small amounts. And then there's Flynn's Devil List of the 40 most problematic chemicals commonly found in schools, and we have found most of the items on the Devil's List in Florida schools. Okay, let's get started. The first thing to do is to get dressed for the job. And that is, for this would include a chemical-resistant apron. I prefer an apron with pockets in it so I can keep my tools. Or if you don't have one like that, you can always get a nail apron from Lowe's or Home Depot. They come in very handy. Of course, you'll need some safety glasses. And gloves. Gloves are very important to wear whenever you're handling chemicals. These are nitrile gloves. They're not resistant to all chemicals, but they do a good job on most. Never use latex gloves when you're handling chemicals because they're virtually transparent to most chemicals. If the inventory hasn't been done in some years, a mirror is a good thing to have so that you don't have to touch the container. You can just orient the mirror so that you can see and read the label. You just have to learn to read backwards. Then you'll need a sharp pencil. I prefer to do the inventory with a pencil because so often you will find another container of the same chemical in another area of the storeroom, and so that way you can modify the total amount. This is the inventory list that DEP also has on its website, and you can download it. It has most of the chemicals that you're likely to find in a high school or middle school situation. They're done alphabetically, which is not the best way to organize your chemical storage situation. But you can make your own inventory, whatever suits your purpose the best. I use the alphabetical one because I come across all kinds of different storage techniques. When doing a chemical inventory, you need to look everywhere, not just in the storage area itself. You need to look in the fume hood and desk, drawers, refrigerators. You'd be amazed at where you might find some chemicals. Some things I've noticed about this particular storage area is that there are chemicals that are above eye level. That's not a good idea because I'm going to have to use a little stool to be able to read the labels on these chemicals. Also, there is not posted any system for chemical organization in this particular storage room, and it should be. You should have either a Flynn system, which many teachers use, ChemSafe has a system, Fisher does. It really doesn't matter which one you use, but it should be used. It appears to me from just looking at this chemicals that he has on the shelf that his is kind of a combination of hazard class and alphabetical order. Alphabetical order is not a good system to organize chemicals because you may well have incompatibles that are stored next to each other. Looking at this shelf right here, I can see an example straight away. He has got powdered zinc metal, which is highly flammable, stored on the same shelf as sodium chlorate, which is a very powerful oxidizer. So they should never be stored together. And in this case, I would probably remove this straight away to prevent any kind of incompatible reactions. I see he also has some potassium nitrate on that shelf, and that's not a good thing. All right, but I'm going to get started in doing this inventory. I'm using an inventory sheet that you can also get on the DEP website. It is alphabetical order. It has most chemicals you're ever likely to see in a school storage area. And if there's one that's not on the list, you can just add it on the back page. And to do this inventory, you just start very systematically and just do them one at a time. Now, this kind of material that is commercial material is probably not necessary to inventory, like salt, baking soda, tenderizer. These are things that you can buy at Walmart, and they don't need to be on your inventory list. But anything that came from a chemical company should be noted, even if it is perfectly harmless. That's the 5 zeros. We like to see that. That means that this is a non-hazardous chemical. But we look on our list here and see Gar gum. All right, and there are 1, 2, 3, 4, 5, 6 containers, and the total amount is less than, each one is 5, less than 20 grams. So we note that on our inventory list. Say number of containers is 5, less than 20 grams. Okay. Also on this inventory list, it tells you what the hazard of the material is. And in this case, it's non-hazardous. Okay, then we continue on. I don't think we need to do the oats. Sucrose, 0.5 ml aqueous solution. So we go and we find sucrose. Okay. It doesn't have any solution mixtures listed. It just says sucrose, and it notes that it's non-hazardous. So we would just put there 1 container. That's all I see. And then note in parentheses 0.5 molar. And the amount is 120 mils. Okay. And so on. And here I notice already we have some misstored compounds. Manganese dioxide is an oxidizer, and so it should be stored separately from anything that is a reducer, anything that is flammable. And here is an example of a container that's completely empty, so it should be discarded. Now these kits, these Flynn kits, they have several chemicals in them. You need to note which each chemical is separately. And if some need to be stored in a special area, like in the flammable cabinet or the corrosive cabinet, that should be done. But we're going to mark them. There's formaldehyde, 37% solution. Okay, now that's a fairly high-risk chemical. So we might want to store that. It should be stored in the corrosive cabinet. So we'll make a note of that. And note that it is in a kit so that you can find it when you need to use it. I've noticed when I did my first initial survey of this storage room that there are a lot of oxidizers that are just mingled among other chemicals, and that's a rather dangerous situation. So I'm going to go ahead and remove the oxidizers that are potent enough to cause problems. Okay, here he has some hydrogen peroxide, 3%. That's not a problem. That is diluted. But he's also got some 30% hydrogen peroxide, which is a very powerful oxidizer, and it should be stored in a way that you are aware of its hazard and that keep it away from any material that is subject to being oxidized by such a potent oxidizer. So I'm going to take these out and put them in a better place. I see he also has some potassium permanganate. That's also a potent oxidizer. And back here, he also has potassium nitrate, sodium chlorate, stored with finely powdered metal, which is a flammable solid, and that shouldn't be. So I'm going to take these oxidizers as well. Now you can store oxidizers in the general open shelves. However, it's a good idea to put them into some kind of secondary containment to prevent them from having contact with a wooden shelf, which is not a good thing. And also, if there are any spills, it's much easier to clean them up if the container is in like a dish pan. You can just buy them at Walmart. Now, a solution of a nitrate, this is 0.1 molar. Even though nitrates are oxidizers, something this dilute is not a hazard, so it does not need to be handled separately. The flammable cabinet is where you might find your major problems. Frequently there are chemicals in here that are high risk. Especially keep in mind that there are some solvents that are called peroxide formers, and that means that when they get old and exposed to air, they will form peroxides that are extremely flammable and even explosive in some cases. The worst peroxide formers are ethyl ether and cyclohexene, not cyclohexane, but cyclohexene. And we've had several problems with those materials in high school storage areas. So be careful when you're going through the flammable cabinet. This is where you might need to use your mirror in case there's an old bottle that you aren't sure what it is, because you don't want to move or touch any of these bottles that are extremely old, because it is possible that they are peroxide formers. But I'm looking in this cabinet and it appears to be quite new and it's in good condition. Now if it's rust, these little things will rust away and the shelves will collapse. This has happened. That's a very serious situation. But just take a good pre-look and see if you see anything that looks suspicious. And there's not in this particular cabinet. It looks as though everything is pretty new. I can read most of the labels without my mirror. I don't think I'm going to need it, but if I did, it's just a simple way of looking at it. You just hold it like that so you can read the label to learn how to read backwards. Commonly, we will find oxidizers stored in the flammable cabinet, which is the worst possible place for them. Because even though under the DOT regulations, flammable materials and oxidizers are considered the same class, they are incompatible. So an oxidizer should never be stored with flammables. And I see here on the other side, just on the other side of the flammable cabinet, that there are some indicator solutions that are dissolved in alcohol, so they are flammable. These materials need to be kept in the flammable cabinet. This cabinet is their corrosive cabinet, but it's not marked. It should be marked as acid, and it's best if you can have two cabinets, one for acid and one for bases, but if you have only one, let's store acids in it. And here again, this is a common source of problems. They used to make acid cabinets out of metal, and of course, they deteriorated pretty rapidly. So you need to check the condition of your acid cabinet to make sure that if it is metal, that the little struts holding up the shelves haven't rusted away, because this can cause a real serious problem when the acids fall and mix together, particularly if you have incompatibles in your acid cabinet. So let's look in here. Yes, hydrochloric acid, 6 molar. That's a good place for it. Okay, I see a problem already. It's got vinegar, but he also has acetic acid. Now, acetic acid is one of those chemicals that has two hazards involved with it. One is it's a corrosive, of course, but the second is that it's a flammable. It has a flash point of about 100 degrees Fahrenheit, which clearly makes it a flammable material. And it's also a corrosive, and flammability is considered a more high risk than corrosivity. Therefore, flammable organic acids in concentrated forms, doesn't matter if they're diluted, should be stored in the flammable cabinet. If you have any nitric acid, it needs to be stored separately from all other acids. Many of these acid cabinets will have a little special place to put the nitric acid. I don't believe that there are any in this. I do see that there is acetyl salicylic acid stored in here. That's aspirin. It's not really a corrosive. The organic acids, particularly the high molecular weight ones, aren't corrosive in solution. So it doesn't need to be in here. It can be stored in the general storage. But here again, you just need to go through each little bottle and container and put it on your sheet. Here he has sodium hydroxide stored in with the acids, which probably isn't a good idea. So it would be better if you don't have a cabinet, a corrosive cabinet, that's dedicated to basic solutions. You should store them in general storage, not in the acid cabinet where they might react. Sometimes you'll see how that happens when you store ammonium hydroxide and hydrochloric acid in the same cabinet. The fumes coming out, even if you have the lids on tightly, will react and make these crystal wigs like on the bottles. So now a little solution to the problem of things getting misshelved after you're through using them is to indicate where their proper category is by just the little stickers that you put on the containers. Be sure to put it on the container and not the cap, because caps can get reversed and put in the wrong bottle. But for example, this Scholar Chemistry, they've already done that for you. They have the green stripe. That means that it is general storage. But you could still put this on there so that when you reshelve these items after you've used them, you'll know right where to put them. And you might have yellow for the oxidizers. That's the color that seems to be pretty standard. So we'll put that on there. And then red, or shocking pink is as close as I could get, for flammable materials. See, oh, here's this little container, little bitty container of phenolphthalein that is flammable. See, it's got the red there, but you just want to see it really well. Just put it on there so that you'll know that when you're putting things back where they belong, you put them back where they belong. Now, occasionally you will find a really old chemical, and they're the ones you need to pay careful attention to. Like I see one right here, and I see that it is a harmless chemical, potassium bicarbonate, but you can tell by the antique-y looking label that it's really old. There's a few tricks to make a guess as to how old. For example, the use of a zip code and an address was made mandatory in 1967, and this address has no zip code, so we know it's older than that. So, and here it says it was inventoried in 1968. So this is a very old chemical. But it's harmless. Potassium bicarbonate is probably still good, but you might want to take it out of service. If you haven't used it in 68 years, you're probably not going to use it. Another useful trick when you are putting these little stickers on the containers of the material is that if you know this material is a regulated hazardous waste, and you can find that out by looking at EPA's website. They have a list of materials that are hazardous waste, either because of their characteristic or because they're listed. So they have two categories, characteristic waste and listed waste. This would be a characteristic waste because it is a strong oxidizer. So I would put a little sticker on there and just write HW or something of that sort, so that you know when it comes to the time to dispose of it that this is a regulated waste and you can't dispose of it in the trash. You can't put it down the drain. It has to be handled as a hazardous waste. You also need to look in the classroom to be sure there aren't any chemicals stored here. It's not a good idea ever to store any chemicals in a classroom. They should be returned to the storage area after the day's experiment. A common place you might find chemicals in the classroom is in the teacher's demonstration desk. So just go through all the drawers to make sure that something hasn't been put in there inadvertently and forgotten about. Also on the benches. They shouldn't be left on the benches after the experiment. They should be put away promptly. Put them away and then inventory them. And here again, look at all the drawers to see if some student has stashed something away where it doesn't belong. This can take a long time. Here's an example of a material that has been misplaced and could well be forgotten about. Fortunately, it's not an extremely toxic chemical. Also, the fume hood is not a place to store chemicals. The fume hood is for doing procedures or experiments that require excellent ventilation. And if you have materials up against the baffle in the back, it's not going to be able to be as efficient as it needs to be. So this is a very bad idea and should be highly discouraged. So these materials should be inventoried and put away. Remember to look high and low. I see some materials down here low on the floor. Chemicals should never be stored on the floor. Fortunately, these are empty. Also look high. You shouldn't have to use a ladder to check out these materials to see what's in them, to be sure that there's no chemicals in them. Don't forget to check the refrigerator. Make sure that there are no chemicals stored in here. It's a bad idea. Yeah, nothing in here but somebody's lunch. That's good. After you've done your inventory, you might have realized that perhaps you don't need 15 pounds of potassium hydroxide and you want to dispose of 10 pounds of it. And you found other chemicals that you just have too much of or you don't use them anymore and you want to do away with them. So what can you do? First thing you need to do is determine what your status as a hazardous waste generator is. Most schools are what are called conditionally exempt small quantity generators. Hazardous waste management is regulated by a law called the Resource Conservation and Recovery Act of 1976, or RCRA for short. And it requires that generators of hazardous waste dispose of the waste properly and keep a record of the disposal of that waste. But since you are probably a conditionally exempt small quantity generator, the only requirement for you is to ensure that any hazardous waste is disposed of properly. The definition of a conditionally exempt small quantity generator is a school that produces less than 100 kilograms of hazardous waste a month. Or, however, if you produce more than a kilogram of what is called a P-listed waste in a month, then you're a large quantity generator. That's another reason not to have any P-listed waste in your storage area. We have on DEP's website, they do have a chart that'll show you what P-listed waste that might be in a laboratory are. Also, a lot of the materials you have here are not hazardous at all, so they can be disposed of as ordinary trash. DEP also has on its website a school chemical cleanout cheat sheet, which is a way that you can match up cations and anions that if a chemical contains these two, then it is non-hazardous and can be disposed of as ordinary trash. So if you are a conditionally exempt small quantity generator, there are several disposal options at your disposal. You can give it away. Ask other teachers if they could use this material in their classroom or other schools in the district. Some school districts have a online inventory where you can see what other teachers in other schools have before you buy a chemical. You can treat it. Small quantity generators who are conditionally exempt are allowed to treat their waste. And you could chemically destroy waste, and Flynn Catalog has some excellent ideas on how to dispose of small quantities of hazardous waste. You can evaporate a solvent if it's a non-hazardous solvent, mostly water. It is not allowed to evaporate flammable solids in order to dispose of them. Some substances can be poured down the drain, but you have to be very careful about doing that because some materials like chlorates, perchlorates, azides, and picrates can cause the formation of explosive salts in metal drains. So that should be avoided. Also, you have to meet the pre-treatment standards of your sewage treatment plant, and that's not easy to do. For example, a standard for copper going down the drain is 8 parts per million, and that is the equivalent of a 10 to the minus 4 molar solution of copper sulfate, which is not really useful reagent in a high school. So putting it down the drain should be only for non-hazardous materials. You can throw it in the trash if it is a non-hazardous item. Don't just put it in the waste can, however. Put it in a box, mark the box, non-hazardous, school chemicals, suitable for landfill disposal, and put your name and number on it. It's preferable if you hand deliver it to the landfill or to your local hazardous waste center. For assistance in disposal of chemicals, contact the person in your county who is responsible for hazardous waste management. A list of these contacts is available on the SC3 page of DEP's website. For more information about the SC3 program, several documents, including the chemical list I have mentioned, are available on DEP's website, dep.state.fl.us. Just do a site search for SC3. This notebook includes general information, including list of especially hazardous chemicals. Here is a how-to manual for chemical management in schools and simple techniques for identifying unknown chemicals commonly found in schools. We hope that this video has helped you plan and perform an inventory of your school's chemicals so that you can ensure that they are being correctly stored, recognize imminent threat and high-risk chemicals, note any chemicals in excessive amounts are no longer being used. Please contact DEP for any needed assistance to ensure that your school provides a safe environment for you, your students, and your community.